we need a rational function that has two x-intercepts. Now, if you think about the function y equals 1 over x, this has a vertical asymptote at x equals 0. Sorry, that's the horizontal asymptote. And it has a vertical asymptote at x equals 0. Because if you had a 0 for x, you would be dividing by 0, which is not allowed. So if you think of a rational function as being like 1 over x, what it looks like, and I can't draw this very well, but we're going to go to Desmos in a minute and look at what it really looks like. But it would look something like this, and it would never cross the x-axis. So if in 1 over x squared, well, that gives us this, which still doesn't cross the x-axis. But if I subtracted 1, well, that would take each of these and move it down 1. And now I think that this is going to be crossing at -1 and 1, but we need to have it cross here. So if you remember how transformations work, I can shift that whole thing to the right, and I really want it to move. If this asymptote has to straddle 1 and 2, I really want it to move 1.5. So if I just take my x and move it 1.5, you subtract from x to get it to move right, I think we'd have this, because now our asymptote is going to be at 1.5, and we're going to scoot everything over 1.5. So this is going to actually cross at 2, and this one, I think, is going to cross at 1. Now, we're going to go to Desmos and see if this works. And if it doesn't, we'll adjust it until we have y equals 0 with x equals 1 and x equals 2. So I'm going to go over here and share my screen with the Chrome tab, which is Desmos. And so I'm going to have it graph 1 over x, just so you can see that that's never going to cross the x-axis. Now, if I instead make it 1 over x squared, now we can see that they're both going up, but they still don't touch the x-axis. So if I shift this down 1, look at that. Now it's crossing -1 and at 1. But I really want it to cross at -1 and 2. So I may have to make it skinnier. But what I'm going to do right now is I'm going to scoot it to the right to get the asymptote to be between 1 and 2. So I am going to make this x minus 1.5. Now that scoots it over, but my x's are not. So I'm going to have to figure out how to get this to skinny up some. So I'm wondering if I would put a 2 here, that does make it skinnier, but then I would have to make this a 3. And there it is. It has a y-intercept. Well, here where y is 0, x is 1, x is 2, and they can't really show it, but we have a vertical asymptote here I can show it at x equals 1.5. And let's make it yellow. We'll make it orange and dashed. There we go. So we've moved the vertical asymptote from 0 over to 1.5, and then we had to multiply the x by 2 to skinny it up so that there would only be 1 unit between these x-axis crossings. And that, I think, is your answer. So the actual rational function that will give you those characteristics is this, the one in red. So if we bring that back over, oh, you know what I can do? Let me go back, and I can copy. Well, that's okay. We'll just write it here. So what I really need here, I was very close, but I need to double all this. This would be 2, and this would need to be 3. And that would be your function. And it satisfies these criteria that when y is 0, x is 1, and when y is 0, x is 2. And that's the answer.